It is crucial to report NEC National Electrical Code violations to the owner or master electrician. Failure to follow the NEC rules and neglecting safety regulations can lead to serious consequences such as electrical fires. Overcrowding boxes with wires can lead to overheating and electrical fires. Short circuits can occur. Excessive wires in a box can increase the risk of short circuits, which can damage equipment and cause injuries. Arc flashes are another potential hazard. If a short circuit occurs in an overcrowded box, it can create an arc flash that can cause severe burns or other injuries. When faced with these situations, there are several options to consider. Firstly, while it may be tempting to avoid conflict by keeping quiet, this is not the right approach when it comes to safety violations. There is a duty to protect yourself and others from potential hazards. Secondly, if you feel comfortable, you could try discussing the issue with the foreman. However, be aware that they may not be receptive to your concerns. Thirdly, reporting the issue to the master electrician or the site owner is the most direct and effective way to address the problem. They have the authority to enforce safety regulations and hold individuals accountable for violations. Reporting violations has several benefits, including enhancing safety. Reporting violations helps ensure that the worksite is safe for everyone. Protecting yourself is another benefit. You may face retribution or even dismissal for speaking up about safety concerns. However, reporting violations can protect you from personal injury or legal liability. Improving the company's reputation is also a plus. Companies that prioritize safety demonstrate responsibility and professionalism, which can enhance their reputation. Here are some additional tips to consider. Document your observations. Keep a record of any safety violations you witness. This can be helpful when reporting the issue. Be respectful. Even though you may be frustrated, it's important to remain professional and respectful when raising concerns. Be prepared to provide solutions. If possible, offer suggestions on how to address the violations in a safe and compliant manner. Here's some further information about the specific hazards mentioned. Electrical fires can start due to several factors related to code violations. Overloaded circuits occur when too many devices are connected to a single circuit, exceeding its capacity. This can cause the wires to overheat and ignite nearby flammable materials. Loose connections can create resistance, which generates heat. Over time, this heat can damage the insulation on the wires and cause a fire. Damaged insulation exposes the bare wires, increasing the risk of short circuits and electrical fires. Using the wrong type of wiring for a particular application can also lead to overheating and fires. For example, using undersized wires for a high current appliance can cause them to overheat. Short circuits are another major concern. These occur when there is an unintended low resistance connection between 2 points in an electrical circuit. This can cause a large amount of current to flow through the circuit, generating heat and potentially starting a fire. Causes of short circuits include damaged insulation, loose connections, and foreign objects coming into contact with live wires. Arc flashes are among the most dangerous electrical hazards. An arc flash is a type of electrical explosion that occurs when there is a short circuit or other electrical fault in the air. The intense heat and pressure from an arc flash can cause severe burns, blindness, and even death. Factors that contribute to arc flashes include dust, condensation, corrosion, and improper work procedures. To minimize these risks, it's essential to adhere to NEC guidelines for box fill. NEC 314.16 covers conductor fill. This section specifies the maximum number of conductors allowed in a box based on the box size and conductor size. Proper box fill is crucial for preventing overheating and ensuring that there is enough space for the wires to dissipate heat. Overfilling a box can lead to several problems, including difficulty in making connections, increased risk of insulation damage, and potential for electrical fires. When calculating box fill, each conductor that terminates or passes through the box counts towards the total fill. This includes equipment grounding conductors and bonding jumpers. Certain devices, such as switches and receptacles, also count towards the box fill. Each device is typically counted as one or two conductors, depending on its size and configuration. Cable clamps and fittings that are inside the box also count towards the total fill. It's essential to consider these components when calculating the maximum number of conductors allowed in the box. The NEC provides tables and formulas for calculating box fill. These resources should be consulted to ensure compliance with the code. The NEC also addresses other aspects of electrical safety, such as proper grounding and bonding. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding ensures that all metal parts of an electrical system are electrically connected, reducing the risk of voltage differences and electrical shock. Regular inspections and maintenance are essential for identifying and correcting potential electrical hazards. Inspections should be performed by qualified electricians who are familiar with the NEC and local electrical codes. Maintenance tasks include tightening loose connections, replacing damaged wiring, and ensuring that all electrical components are in good working order. Proper training and education are crucial for electrical workers. Electrical workers should be trained on the NEC electrical safety practices and the proper use of tools and equipment. They should also be provided with ongoing education to stay up to date on the latest codes and technologies. Using the right tools and equipment is also essential for electrical safety. Electrical workers should use insulated tools, wear appropriate personal protective equipment, and follow safe work practices. They should also inspect their tools and equipment regularly to ensure that they are in good working order. Always de-energize circuits before working on them. This is the most important safety precaution that electrical workers can take. Before working on any electrical circuit, it's essential to de-energize the circuit and verify that it is de-energized using a voltage tester. Use lockout-tagout procedures to prevent the circuit from being accidentally re-energized. Always follow safe work practices. Electrical workers should follow safe work practices at all times. This includes wearing appropriate personal protective equipment, using insulated tools, and working in a well-lit and ventilated area. They should also be aware of potential hazards and take steps to mitigate them. If you are not comfortable working on an electrical circuit, don't do it. Electrical work can be dangerous, and it's important to know your limitations. If you are not comfortable working on a particular circuit, call a qualified electrician. The NEC provides specific guidelines for working with different types of electrical systems, including residential, commercial, and industrial systems. These guidelines cover everything from wiring methods to overcurrent protection. When working on an electrical system, it's essential to consult the NEC and follow the guidelines for that specific type of system. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It's essential for electrical workers to stay up to date on the latest edition of the NEC to ensure that they are following the most current safety standards. Local jurisdictions may also have their own electrical codes that are more stringent than the NEC. Electrical workers should be familiar with the local electrical codes in their area and follow them accordingly. Regular electrical inspections can help to identify potential hazards and ensure that electrical systems are in compliance with the NEC and local codes. Electrical inspections should be performed by qualified inspectors who are familiar with the NEC and local codes. When working on electrical systems, it's essential to use approved materials and equipment. Approved materials and equipment have been tested and certified to meet safety standards. Using unapproved materials and equipment can increase the risk of electrical shock, fire, and other hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. It's essential to use the correct size overcurrent protection device for each circuit to ensure that it is properly protected. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. GFCIs are required in certain locations such as bathrooms, kitchens, and outdoor areas. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Electrical safety is everyone's responsibility. By following these tips, you can help to prevent electrical accidents and injuries. Remember, when in doubt, consult a qualified electrician. They have the knowledge and experience to safely and effectively address any electrical issues. Promoting a culture of safety on construction sites is paramount. This involves ongoing training, regular safety meetings, and a commitment from management to prioritize safety over productivity. Encouraging workers to report safety concerns without fear of reprisal is also crucial. It's important to remember that safety is not just a set of rules and regulations, it's a mindset. By embracing a culture of safety, we can create a work environment where everyone is protected from harm. The NEC also provides guidelines for specific types of equipment and installations. For example, there are specific requirements for swimming pools, spas, and hot tubs. These requirements are designed to prevent electrical shock and ensure the safety of people using these facilities. There are also specific requirements for hazardous locations, such as areas where flammable liquids or gases are present. These requirements are designed to prevent explosions and fires. When working in a hazardous location, it's essential to follow the specific requirements for that location. This may include using explosion-proof equipment and following strict safety procedures. The NEC also provides guidelines for renewable energy systems, such as solar and wind power systems. These guidelines cover everything from the installation of the equipment to the connection to the grid. Renewable energy systems are becoming increasingly popular, and it's important to ensure that they are installed safely and in compliance with the NEC. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. By understanding and following the NEC, you can help to prevent electrical accidents and injuries. Remember, electrical safety is everyone's responsibility. The authority having jurisdiction, or UJ, is the entity responsible for enforcing the NEC and local electrical codes. The AHA may be a local government agency, a state agency, or a private organization. It's important to be familiar with the AHA in your area and to follow their requirements. The AHA typically requires electrical permits for new installations, alterations, and repairs. Electrical permits are designed to ensure that electrical work is performed safely and in compliance with the NEC and local code. The AHA may also conduct electrical inspections to verify that electrical work has been performed properly. Electrical inspections are an important part of the electrical safety process. The NEC also provides guidelines for energy efficiency. Energy efficiency is becoming increasingly important, and the NEC includes provisions to promote the use of energy-efficient materials and equipment. By using energy-efficient materials and equipment, you can save money on your energy bills and reduce your environmental impact. The NEC also provides guidelines for electrical system design. Proper electrical system design is essential for ensuring that an electrical system is safe, reliable, and efficient. The NEC includes provisions for calculating load requirements, selecting appropriate wiring methods, and providing adequate overcurrent protection. When designing an electrical system, it's important to consult the NEC and follow the guidelines for that specific type of system. The NEC is a living document that is constantly evolving to reflect changes in technology and industry best practices. It's essential for electrical workers to stay up to date on the latest edition of the NEC to ensure that they are following the most current safety standards. Electrical safety is an ongoing process that requires continuous learning and improvement. By staying informed about the latest codes, technologies, and best practices, you can help to prevent electrical accidents and injuries. Always remember to prioritize safety above all else. The NEC is a valuable resource that can help you to work safely with electricity. Take the time to learn about the NEC and to follow its guidelines. By doing so, you can help to protect yourself, your coworkers, and the public from electrical hazards. When reporting a safety violation, it's important to be specific and detailed. Provide as much information as possible about the violation, including the location, date, time, and individuals involved. It's also helpful to include any photographs or other documentation that supports your claim. When reporting a safety violation, It's important to remain calm and professional. Avoid making accusations or expressing anger. Instead, focus on the facts and explain why you believe the violation is a safety concern. When reporting a safety violation, it's important to follow the proper channels. Start by reporting the violation to your supervisor or foreman. If your supervisor or foreman does not take action, report the violation to the master electrician or site owner. If you are still not satisfied with the response, you can report the violation to the AHA.